Morning, Stats fans. How we doing this fine Monday morning? Yes, it is a Monday morning. What a beautiful weekend it was. It was just beautiful to go outside and be able to be outside when it's really warm out, do some things outside. It was really, really nice to be able to do that. A little bit chillier this morning, but that's okay. Hope everything's going well with you and your family at home. Hope everybody's staying away from illnesses, keeping your social distancing out there. Let's continue to do our part so we can get ourselves back to some sort of normalcy here. You've been doing a great job with the material. Continue to keep up with the material as we go along. Once again, we are close to the end here. We are that close to the end. We have hypothesis testing. We'll deal with t-tests today. We got some chi-squared, and we also then have two mean hypothesis testing that we have to go through. So that will be the rest of this week. Looking for a quiz. We'll get some additional practice. Probably beginning of next week, chapter test, unit tests over this, and then we will start reviewing for the final at that point. So we are close to the end in regards to the material. Let's continue to do what we need to do to complete what we had to complete. Today we're going to talk about the t-test. Last week we talked about all the z-testing that we did, and just like with confidence intervals and the t-test compared to a z-test, there's not that much different. The only difference is going to be where you find your value on your t-table. Okay, you'll still be using your t-table here, but the critical values that you find will be on your t-table. The t-test. We deal with the t-test. It's a statistical test for the mean of a population. When you're normally distributed or approximately normally distributed, and your sigma is probably unknown there, which means your standard deviation is not known, but your sample size, once again, the key to this is your sample size is less than 30. When your sample size is less than 30, we have to go to what is called a hypothesis testing with a t-test. We have our degree of freedom, once again, nothing difficult to calculate here, it's just n-1, that's your degree of freedom. It's going to be, the traditional t-test is the same as the t-test, except for the population is smaller than 30. So you'll still get this. If I look at a two-tailed test, you'll be given an alpha value, a some value here. We have non-critical, we have critical, we have critical. This was our critical value. But now this is going to be a t value rather than a z value. Okay, it's the only thing is different. And if you look at your t-table, once again, the t-table is probably one of the most important tables that we will work with in this class because of the amount of information that you can pull off the t-table. Let's take a look at a problem. Okay, very similar type of problem we did before, but now what's going to happen is we're going to limit the sample size to 20 buses. Study found the average stopping distance at 50 miles per hour is 264 feet. A group of automotive engineers is the same problem we did before. I just changed the sample size. Decided to conduct a study for 20 buses rather than 60 or 50. Average stopping distance was 262.3 feet. Standard deviation of 3 feet. Tested claim the average stopping distance of this is actually less than the 264. Okay, we are still going to start the same. The null and the alternate hypothesis. We are comparing the mean. What is established here? Our established value is 264 feet. But we want to know if it's actually less than the 264 feet. So what we hope is true, once again, that's our alternate hypothesis. What we hope, or what the scientist is trying to hope is true, is it's going to be less than 264. SpongeBob opposite. The null hypothesis is opposite to the alternate. So we have mu is greater than or equal to 264. Once again, remember equality will always go with the null hypothesis. So what we have here is we have a sample size of 20, our degree of freedom, 20 minus 1, which is 19. We have their mean is 262.3 feet. The standard deviation is 3 feet. And we have an alpha value of 0.01. So let's go to our bell-shaped curve. Now the question is this a one-tail or two-tail test? Okay, we look at the alternate hypothesis. We have less than and greater than there, so that's going to be a one-tail. And the alternate hypothesis tells us which direction. It is to the left. So we have a one-tail, and this is a left, which means our critical value is over here. We have to find our critical value. So we look at our degree of freedom of 19, and we have a one-tail alpha value 0.01. So I'm going to go to my t-table. I'm going to go to one tail, which is the middle row on top, and I have to go to 0.01. Make sure you go to 0.01, not 0.10. So one tail, 0.01, and then trace it down to my degree of freedom of 19. And I get 2.539. Make sure, see, 0.01, go down degree of freedom of 19, 2.539. And since we're a left tail, we need to throw a negative in with that. This is non-critical. This is critical. Non-critical and critical. So we have to find a t-test value, which is x bar minus mu divided by standard deviation, square root of n. This is not changing. So we have 262.3 minus our 264 over standard deviation of 3 divided by square root of 20. Now remember what we did with this, with your calculator, do the top value. So we have 262.3. So we have 262.3 minus 264. Hit your enter. Maybe. We get negative 1.7, and then just hit your divide by parenthesis, that will quantify 3 divided by second square root of 20. Okay, so you can just add it in like that. And we get negative 2.534. Well, if I look at my critical value is negative 2.539. So my value is right there, real close to my critical value. But I'm still in the non-critical region. So we fail to reject the null hypothesis of stopping distance is equal to 264 feet. But we are so close here. So as a person that would be doing the study, I can't reject my null hypothesis. I may not accept it, but I fail to reject it. But I'm so close here, that would be, to me as an investigator, I would go back and start doing more and more tests because I'm so close to this and my sample size is small. But we failed to reject. Let's look at that last one. Average family size was reported to be 3.18. Random sample of families in a particular school district resulted in the following sample size. We're giving a set of data. Alpha value 0.05, average family sample size differ from the national range. So we start with our null and our alternate. Key word here is differ. So our alternate will be mu does not equal to 3.18. So mu here would equal 3.18. Now the difference is I don't have a set of data here anymore. I don't have the data given to me, or my statistics. And the other problems, I've been given X bar, my sample mean is this, my standard deviations, I'm not given that. So what do? Well, if you remember back to what our calculator will do for us. Our calculator will do a lot of things for us. It will calculate a mean and a standard deviation. I would suggest you utilize that, KYC. So if I go to my stat button, I go to edit, I can list my data values, and I've already done that, so I don't have to worry about doing it right now. Okay, you can list all the data values that you have here. So go ahead, enter the data values in. Once you enter your data values in, if you go back to your stat button and go to calculate, one variable statistic. This will give us all of our data values. My sample mean 3.833. My sample standard deviation, I want to utilize that, not my population, because this is a sample here. 1.434. So my X bar is 3.833. My standard deviation, I'm sorry, I forget it, 1.434 or 1.435. And once again, write these out for me, so I can see that you know what you're doing here. My sample size is 24, which means my degree of freedom is 23. And my alpha value 0.05. So once again, I'm going to go to my bell-shaped curve. My bell-shaped curve here. Is it one tail or two tail? Right, two tail. So I got two tail here. We're two tail. My degree of freedom is 1 minus that, so I should have a 23. So now, once again, I go to my t-table. Go to my t-table. I have a two-tail test, so I'm going up top with my two-tail. I scroll over to 0.05, and then slide down to my degree of freedom of 23, which is 2.069. And this one is negative. We have non-critical. We have critical. Critical. We go to our t-test value, which is x bar minus mu divided by standard deviation, square root of n. 3.833 minus 3.18 divided by our standard deviation 1.435 divided by a square root of 24. 3.833 minus 3.18, you get 0.653. Then I'm dividing by parentheses 1.435 divided by the square root of 24. Oops. And we get 2.229, which throws me out in a critical region. So we can reject the null hypothesis of average house size of 3.18. Now what I want you to do also, let's go back to our calculator again. Let's go back to our calculator. Let's go back to my stat button. Let's go to my tests over here. We're going to do a t-test. So we have data and we have statistics. Now we don't have the statistics, so I guess we did calculate it. But what your calculator will do for you is we can also do data here. Our population mean is 3.18. And we're pulling a list from L1. That's the list that we put everything into. My alternate hypothesis is not equal to, so I have that, and let's go down to calculate. And if I calculate this, or I'm sorry, draw this, we get our t-table, which is a little bit higher, but we get to 2.2311, and we get a p-value, once again, what we talked about last week, 0.0357. Which is less than the alpha value 0.05, which we can utilize also to reject our null hypothesis. So your calculator will do nice things for you, and the nice thing about your calculator, it shows you this bell-shaped curve. It shows you the bell-shaped curve here, which is sort of nice, and the areas that are shaded in. Okay, this is the t-value, this is a t-test. I posted a worksheet that involves the utilization of the t-test to be able to calculate and test the hypothesis. Please continue with the material. Looking for this week. Like I said, I don't think I'll do a quiz this week, but you'll probably have an in-class assignment sometime this week with the hypothesis testing. You have an in-class assignment, and then next week we'll have a unit test over everything that we've talked about with respect to hypothesis testing. Other than that, I have nothing else for you today. I miss you guys. I wish we were sitting here in class, but we're not there. So enjoy your day. Continue to keep up with the material. We are almost done. We're very close to being done. Adios. We'll see you folks. See you tomorrow.